Hello everyone. Here let me introduce our MPB 2.0 solution. Our MPB 2.0 solution is based on SONiC switch. From the picture we can see we add a packet broker container onto the SONiC switch operating system. We change it from a SONiC switch into a packet broker. There are three advantages. The first one is flexibility and programmability because it's running on an open SONiC operating system. The second one is it's based on commercial switching ASIC. It can gain high performance and line rate forwarding with a very cost-effective price. The third one is containerized service for modular deployment and continuous evolution. Okay, some basic information about our packet broker solution. Then we can check the web UI. Okay, now let's check the web UI of the packet broker. The first one is overview. That's the dashboard. Here we can see the link status. Yeah, it can check the port, whether the port is up or down. When it's inserted, we can check the optical module info. Here we can see the details of the inserted module. Yeah, we use different color to mark up and down. So currently there is no port, no module inserted, so ours shows down. Then here's the information, the IP address, the product name, serial number, and version. Also the system status, temperature of the device. Yeah, we have temperature for different fan, switch, and mainboard. Also there is the status for different fan. We can see the status, the RPM, and also status for power module. Also total throughput. Yeah, next one we can check the port configuration. Yes, for port configuration, the first one is port type. We can see there are multiple types for port. By default, they are all marked as hybrid. For hybrid, it can be used connecting for any devices. For TORs, it's usually configured as connecting analysis tool or script TORs. For network, this one is usually for connecting another switch for receiving mirror traffic. For service, just as I mentioned, our packet broker is based on SONiC switch, so it can function as packet broker and meanwhile function as SONiC switch. So when the port is setting as service, it means this port is used for switching and routing. Yeah. It has a limitation to the usage for a packet broker. You can only use mirror policy to copy the traffic from this port. Okay, that's a port type. Second one is type. From type here we can see it can be regular, IX, and TX, and also it can be used as loopback. The loopback interface in packet broker is for some operation. For example, one policy, if you want to do some operation to traffic, but one policy is not enough. You need to use two policy to finish the operation. You can firstly use operation 1 to forward the traffic to a loopback interface. Then the second operation to operate the traffic from the loopback interface to the egress interface. Yeah. This model is based on 100 gig port Also, we have lower model and higher model. Yeah, we have very full product line from 1 gig to 800 gig. All of them support to be a packet broker. Here we can see it supports port split. For this one, it can be the 100 gig can be split into 4 interface, 4 by 25 gig. Okay. The next important one is the tunnel strip. Yeah, we configure tunnel strip on the port. Here we can see it supports all these 8 types of tunnel strip. And by default, the hash mode is also configured on port, and the default one is source destination IP port. Yeah, you can modify this in the configuration in the forwarding policy. I will show you later. Also for network config, this one is for configuring MAC address and IP address. We configure IP address here usually for the GIE, ER span, and VXLAN, yeah, to acting as the tunnel endpoint. Okay, that's basically the configuration of the interface of the port. Okay, the next one is port statistic. Yeah, this one is very important to monitoring the packet broker working status. Yeah, if we want to check the load balancing, check whether traffic is successfully forwarding from one port to another port, we can check the statistic here. Yeah, it's very convenient. Okay, now we move to the policy. Yeah, from the policy here we can see there are 3 types of policy. The first one is forward. This one is for mirrored traffic or tapped traffic. When we receive mirrored or tapped traffic from port A, we can use forward to forward it to port B. Yeah. For span, it's usually used for when there is production traffic, when this packet broker is working as it's also working as a switch. You can use span to copy the traffic, to mirror traffic. The difference between span and R-span is that span it supports multiple egress port, and R-span supports only one port, egress port, but it supports adding VLAN tag. Span doesn't. Okay, it's basically the difference between these 3 types of policy. And we can see for each type of policy it supports 4 subtypes: L3, L3v6, L2, and EX. For L3, it means it supports filtering policy as the IP field. Now we can see the source IP, destination IP. Yeah, it's from the IP layer. And for LCV6, it's also easy to understand. That's for IPv6. The fields are all from IPv6. You can see that it's a little different from IP. And for layer 2, for L2 is for layer 2. And we can see the outer VLAN is type, source MAC, destination MAC. And what is EX? EX is the extension for layer 2. Let's just check it. It has the source IP, outer VLAN is the type, source MAC, destination MAC. Also TCP flag and VNI. Yeah, just the extension to L2. Okay. Except this basic policy introduction, we can check some other features. This one is for display hide column setting. Okay. This one is for setting rows. It offers different fields as such condition, and this one is using for priority adjustment. By default, the priority is from top to bottom. Yeah, the first one is first match, the second one is second match. You can use this tool to adjust the priority. Okay. This one is filter for using to choose to find the column the policy you want to check. Okay. Then we check the egress filter list. This policy is for forwarding policy. When you forward traffic from port A to port B, before port B release the traffic to the peer device, you can set a filter here, for example, to block some traffic. Yeah, here you can see you can set the policy as line, and for example, the egress port as C2, you want to block this traffic, then this traffic will be blocked before it's sent to the peer part. Okay, next one we check the mirror policy. Here we can see it supports span, R span, ER span, all these three types of mirroring. For span and R span, we have just introduced the difference between them. For span, it supports multiple egress port. For R span, it supports only one. When we support multiple, it will it won't work. It only supports one egress port, but it supports VLAN tagging. And for ER span, here we can see it can send traffic over layer 3 network. Okay, so it requires source IP, destination IP. Okay, that's the difference. For egress port group, here we can see the hash mode. As I mentioned, the default hash mode for port is source destination IP port. You can modify it into another type. Also, it supports customization. Here we can set different type. You can just customize it. Also, we support hash seed modification. Okay, and then comes the leg configuration. Here we can see we support 4 types of leg configuration. The first one is static. This is the basic one. When one port down, all traffic will be recalculated. Yeah, do the hashing to do the scheduling. When we switch it into flexible, for example, when this port is done, only the traffic onto this port will be rescheduled. The traffic onto the other port won't be affected. For weight, we can configure different weight for different ports. For example, this port can hold more traffic, we can set the weight to be higher. And for standby, we can set port with different priority. For example, the max active we can set as 2, and we have 2 ports with higher priority. When one port is done, the port with lower priority will take up the role to forward traffic. That's some introduction of the leg configuration. This is the MPLS parse. It's for MPLS field. For advanced function, currently it supports LLDP. By default, this function is enabled, and we can disable it. System management, some activity log. We can configure the syslog server, and license configuration. System time, it supports NTP and manual. For startup config, here we can see start config saved, save system setting, reset current configuration, and export config, import. This is for managing IP configuration. Also device upgrade. SMP, it's regular, user management, role management, Telecom certification. Yeah, that's basically everything on web UI. Okay, here is some highlights of our packet broker. As you can see, it using spine-leaf architecture, flexible deployment, support both inline and tab mode deployment. Optional DPU module. Yes, some of our models support internal DPU. With internal DPU, then it can install another operating system which can offer advanced features for our packet broker. For example, like SSL decryption, encryption, like deduplication, like TCP reorganization, yeah, something like that. Comprehensive product portfolio from 1 gig to 800 gig. That I have mentioned this before. Centralized controller. Yeah, it supports controller to manage our packet broker. We have such a controller. Also automation ready. Native DevOps Ansible playbook integration. For also building security. Yeah, we know the packet broker is based on SONiC switch. Yes, our SONiC switch supports MACsec encryption. So we make use of this feature to ensure when the collective traffic need to be long distance transmission. For observability, we can see the SONiC switch. It has a container called exporter. Yeah, this exporter is working with Prometheus, and it collects data on the device and for Prometheus to scrap. Yeah, it can gain very high scale observability. Also, there is a nice feature called flowlit load balancing. Yeah, some of our SONiC switch supports flowlit-based load balancing. Yeah, so the MPB, the packet broker, can make use of this function in the lag configuration. We know the MPB packet broker fabric in data center is also encountered with the elephant flow problem. When there is an elephant flow, and it might cause congestion and packet loss. Yeah, we will introduce later in the scenario. Also, high-speed optical connectivity. It supports 400 gig, 800 gig ZR+ for long-haul interconnect and data center extension. Okay, we check the scenarios. As I mentioned before, our packet broker supports inline deployment. You can see the problem here when the egress link operates at a higher bandwidth, but the security tool throughput is far lower. You can use inline deployment to aggregate and load balance high volume traffic across multiple security tools. Yeah, this is a very good example. The second one is our packet broker supports ZR+ module. We can be deployed in DCI link to save the ZR+ module to make the monitoring solution more cost effective. Why we can do that? Because our packet broker is based on beta tested SONiC switch. It allows for secure inline deployment for DCI link, as it shows here. We can see the legacy solution, and it uses tap or splitter to collect traffic, but each link will cost a pair of ZR plus module. In our solution, we don't need to cost more ZR plus module, just as the original. Now we can see the plan here. It's more cost effective. Okay. Just as I mentioned, our packet broker is based on SONiC switch. The SONiC switch has a Docker called exporter. Yeah, it can realize millisecond level monitoring. Now we can see it provides real-time millisecond level precision for system metric. The exporter do millisecond level sampling, which enables it to capture key runtime metrics like queues, buffers, CPU interrupts, and traffic rates and drops every millisecond. Expose them in averages, peaks, and burst duration via Prometheus format. So when Prometheus to scrap the collected data on the MPB packet broker, we can still access to aggregated millisecond level samples, so it can detect microburst. Yeah. Also, the packet broker it supports Ansible deployment. Yeah. And we know Nexium packet broker configuration relies on web UI, CLI operation. So when there are a lot of policies, it's a very hard job for the operator. Yeah. After we use Ansible, yeah, it enables configuration automation via Ansible with the playbook. Yeah, the time would be much lesser there. Great relief. Okay, the next one is about the fully load balancing. Just as I mentioned, some high model of our SONiC switch support this feature, and our packet broker make use of this feature into the packet broker fabric. When there is a elephant flow in the packet broker fabric, it will cause congestion and packet drop. Yeah, after we apply this technology, yeah, it can solve this situation. Next one is the solution we designed for SMB, yeah, small medium business. We know the core requirement of SMB is simplicity, no cost, and easy OEM. Here we put tap, MPB, and traffic processing tool into a single device. It's very versatile and very powerful. Here we can see it functions as an electric tap while port mirroring, because it's a packet broker, it supports port mirroring, and the optional DPU. Yeah, it has DPU inside to enable different role. It can be installed with on top, then it can be used for visibility tool. Also, it can be used for let flow output if there is tools already. Yeah, we can just change the traffic into let flow and send to tools. Also, we can run FusionOS. It's a operating system developed by ourselves. It can offer advanced packet broker features like deduplication, SSL decryption, encryption, and something like that. Yeah, that's what we do for small business. small and medium business. The next one is hardware. That's MACsec. When there is in a multiple point traffic collection scenario, the collected traffic might contain sensitive data. It requires secure long-distance transmission. The next solution is use software-based encryption, but it consumes a lot of resources and cannot scale. So our solution is use the switch ASICs built-in MACsec for hardware-based lightweight encryption at the link layer. Okay. Next one is about the 4-mode load balancing. This one we have just mentioned. It offers different choices to meet different network requirement. Okay, next one is the tunnel decapsulation. Here we can see when traffic in DCI, MAN, metro, and large-scale enterprise is often carried through GIE, VXLAN, and other tunnel encapsulation. But analysis tools cannot handle these complex encapsulated packets. As I showed you before, we can configure tunnel strip on the interface on the port page. Our packet broker supports GIE VXLAN termination and the tunnel strip for all these 8 types. Okay, I guess that's all for the packet broker introduction. Next few times we left for the ET2008, the Asterfusion VPP. Okay, we still have time to do a brief introduction of our Asterfusion VPP router, that is ET2008. Here we can see the datasheet of this router. We can see the CPU information. We check the right part first. Here we can see it uses Asterfusion as the control plane. Asterfusion as a control, that is the SONiC enterprise version of SONiC, and we use VPP as the data plane. That's basically the basic architecture of the software. With this small box, we can realize routing performance as 48 gigabit with 2 million routes. Okay, it's pretty high. And for security, it can realize 40 gigabit IPsec and the SSL processing. With optional PTP SYNC-E module, it can realize 20 nanosecond accuracy and BC support with handover. Also, it supports optional Wi-Fi module, LTE, 5G module, and additional SSD. Okay. So, it's a great convenience for those operators who are already familiar with the SONiC UI, SONiC CLI, to use such a router. It's small and it's powerful. Also, it's user-friendly. Okay. That's basically